Hi everyone, welcome back to Art of the Part. In this video, we're going to take a look at the left side mold of our Arbor Press P2 and MasterCam. And we're just going to be focusing in here on the 3D toolpath gallery, and if you look on the left-hand side of my operations manager, I'm doing this entire part with just a few toolpaths. So I've already finished this, I'm just going to step through this and then we'll begin the walkthrough, but I'll go right-click, isometric, and our first toolpath is going to be an OptiRough using a flat end mill, where we're just trying to remove as much material as possible. The second toolpath is just going to be a copy-paste of that OptiRough, but instead of a flat end mill, we're going to use a bullnose end mill so that we can clean up some of the corners a little bit easier while still recognizing the stock removed from the first operation. The next toolpath is going to be a stock model, and we're just trying to recognize all the material that's been removed from the first and the second operation so that we can use it and verify. I don't want to have to keep running these toolpaths over and over and over again. I just want to reference what's been removed, and then I can move into our fourth toolpath, which is going to be an equal scallop that we can use to finish all the edges down to their final size using a ball nose end mill. So let's go ahead and get started. I'm going to delete my entire toolpath group here so that I don't have any toolpaths active in my operation manager. I'm just going to delete that. And then as a disclaimer, I've already set up my tool library as well as my planes and my stock material. So the first toolpath that I want to take a look at is the OptiRough, and it's going to be located here in the 3D toolpath gallery. It should be the first icon, but if we hit the drop-down menu, I just want to make mention of the fact that we have a roughing selection as well as a finishing selection. So here inside of roughing, we're trying to remove as much material as possible, and then the finishing selection is only going to focus on that final pass. So right now we're just trying to rough, so I'm going to click on the dynamic OptiRough, and this is going to open up your parameters window for that 3D toolpath. Now, this is going to look a little bit different from what we're used to seeing in our 2D selections, where maybe we're just trying to pick like an edge or a continuous chain. Now we're trying to select all the surfaces that are going to be considered for machining. So on the left-hand side of this window, we have our machining geometry, and on the right-hand side, we have our avoidance geometry. They're represented here by the green and the red boxes, and I just want to focus on the machining geometry first because I want to pick all these internal surfaces for the mold. So on the left-hand side of this window for machining geometry, I'm just going to go to the bottom of it, and I should see this mouse pointer. Click on that, and this should start to allow you to make selections to be considered for 3D machining. And I want to make mention of this tooltip window here at the top left. It says select solid face, surface, or mesh, and it gives you a handful of ways that you can select these entities without making it too much of a pain on yourself. For example, if I was clicking on these one by one, I'd have a lot of entities click. However, if I hold down the shift key and I double click on one of these faces, it's going to pick up all the tangential faces in that selection. So click end selection, and you can see now that I've selected 103 entities. And that's currently being shown here in the background with all these faces highlighted in green. Additionally, I have the ability to control my wall stock as well as my floor stock. By default, both these values are currently set to 50 thousandths, and I think that's just a little bit too much. We're going to decrease this down to 10 thousandths, so I'll double click on the cell, I'll type in 0.01, and I'll double click on the cell for floor stock, type in 0.01, and we're not going to worry about the avoidance geometry. I'm going to leave this alone for now, and we'll just jump down here into our toolpath control, which is the next tab. So click on toolpath control, and I'm not really going to make any changes to this window. I want to leave it as the default value, and I'll show you how to come back and troubleshoot this later. The only thing that I want to change here is our cutting strategy. Currently it's set to from outside, which means the tool is going to crash into all these sidewalls to try to cut these surfaces. So we are going to toggle this over to stay inside, and you can leave the compensation here to center. We'll jump down here into our tool tab. And as I said before, we're going to use a flat end mill to try to rough as much material out as possible. So I'm going to use the 5/8 flat end mill here. This is going to be our roughing tool. And I'll just say OptiRough 0.625 end mill for my note. Then we'll move down here into our cut parameters. And inside cut parameters, this is going to look a lot like our 2D dynamic mill, where we can control our step over distance. This is currently set to 25%. You can leave that there. However, now we have the ability to control our step down as well as our step up. So we can make multiple steps in this OptiRough to try to clean up as much material as possible. Typically, I don't like using 100%. I think that causes some errors, especially when we're dealing with like internal pockets. So I try to set this value to maybe a little bit smaller, maybe like 50%. And then I'll also take a look at our step up. I'll turn this on, and it's just going to step up in between all these depth passes to try to clean up maybe a little bit more in that angle. So currently that's set to 10%. I'll update this to 25%. And then we'll move down here into steep shallow. We can technically leave this off, but I just want to see what our selection looks like. If you wanted to, you can turn on minimum depth as well as maximum depth, and currently these are both set to 0. If you click on detect limit for both, it'll actually show you what the highest point of your selection was, so the highest point of this edge, and then the lowest point, which is going to be down here in that pocket. Next, we'll move down here into linking parameters. And this page can be a little bit overwhelming at first, especially if we're coming from like 2D toolpaths where we just have like absolute, absolute, absolute. In this instance, we're just going to make a couple changes. The type here where it says full vertical retract, we can hit the drop down menu and then just update that to minimum vertical retract. Now, this is going to prevent the tool from retracting out to that 2-inch clearance plane every single time that it has to move across the part. You'll notice with these 3D toolpaths that the tool will be moving quite a bit, so try to reduce the amount of times it has to retract to that full distance. For the leads, you have your primary and your secondary leads. You can leave these as default for right now, but you can control if the tool is going to enter horizontally, or you can change it to vertically or none. Like I said, I'm just going to leave this the same for right now, all the default values, and we'll just hit the green check mark to regenerate this toolpath. And you can start to see some errors in our toolpath where the tool is entering into areas that we didn't specify for machining. And this is primarily because we didn't set up any avoidance regions, or we didn't try to control that toolpath using a containment boundary. So I want to take a look at this and verify and show you why this toolpath isn't what we want. So I'll come up here to the top left-hand corner of my operations manager, click on verify. This is going to take a second to load. And then I'm going to turn up my playback speed down here in the bottom to fast because there's quite a bit of toolpath that we need to process, and then I'll hit play to let this run out. And we can see that that tool is basically traveling everywhere except for where we specified in our machining region. We're creating these 2 additional pockets on the left and the right side, and I'm going to tell you that this is not a desirable toolpath, and we'll have to go back into that OptiRough and make some changes to try to contain it to just the mold region of that Arbor Press P2. So let's back out of verify and take a look at that. So let's jump over here into our operations manager on the left-hand side. We'll find that OptiRough toolpath we just created. Double-click on parameters and we can open up our parameters window. Now, there's 2 ways we can go about controlling this toolpath so it doesn't enter in the areas we didn't specify for machining. The first and probably the easiest is to come up here to Model Geometry, so click on Model Geometry, and we have our Machining Geometry section as well as the Avoidance Geometry selection. So right now we don't have anything selected for avoidance, so let's change that. We'll go down here to the bottom right where we have that mouse button to select entities, click on that, and we're just going to select on this entire top face and then click on End Selection, and you can see that our avoidance region is all highlighted here in red. So let's hit the green check mark and let this regenerate. And you can see that did a pretty good job at trying to control that toolpath to just this region here for that pocket. We no longer have the tool entering in the areas that we didn't specify for machining, and if for whatever reason this avoidance region selection doesn't work for you, the alternate way that we can control this toolpath is to use a containment boundary. So really quickly I'll show you how to do that. We'll go back into our parameters. You can see here in the avoidance region we just have one entity selected. If I want to remove that entity, I just select entities once again, and then I clear the selections and then click End Selections, and now I have 0 entities selected. And then I'll jump down here into my toolpath control tab, and we're going to look at the containment boundaries. So the boundary chains right here, we're going to click on the mouse button for the containment boundary, and we just want to make sure that we're chaining here from a solid loop, and we'll select this entire loop on the top face so that all of this gets selected, and then we'll hit the green check mark, and we'll hit the green check mark once again and let that regenerate. And you can see that we're getting the exact same result. We're just using 2 different methods of controlling that toolpath. We're either using the avoidance region to avoid certain surfaces, or we're using the containment boundary to force the tool to stay within a specific area. And I can't tell you if one is better than the other. I'm sure there are use case scenarios for both, but I've had a little bit more luck lately using the containment boundary and controlling that toolpath. So just keep that in mind if you're trying to troubleshoot and you're not getting the results that you want. Now, let's take a look at this toolpath and verify just to double check that we are truly containing ourselves to this region and that we're not going to crash into any of the sidewalls. So we'll move over here in the left-hand side in our Operations Manager. At the top of the window, we'll click on Verify, and then I'm just going to let this play out. So click Play, and you can see that the toolpath is now contained to that region, and we're just traveling around the outside contour of that mold, and we're just stair-stepping down as we go, which is cleaning up as much material as possible. So this is going to take a lot of that cutting pressure off of the next toolpath, which is going to be the bullnose end mill, and then eventually the finishing toolpath for the ball nose end mill. So I'm going to say we did a pretty great job roughing this out, and we can move into the next toolpath, which is going to be a roughing operation using the bullnose end mill. So let's back out of Verify here. And I think I'm just going to copy and paste this OptiRough because I'm really happy with how it performed, and we already have all of our selections populated. So let's move over here to the left-hand side in our Operations Manager and just double check for me that you have a check mark next to that OptiRough we just created. And if you see that, right-click on that toolpath, and from the drop-down menu, I want you to select Copy. And then find your red arrow, and then to the right of that, we'll right click, and from this drop down menu, we'll select paste. So you can see we've copied and pasted that toolpath, and in this second toolpath here, we're just going to double click on parameters to open up our parameters window. Now we're just going to make a few changes here. I'm going to jump over into my tool tab. So inside a tool, we're going to change from the 5/8 flat end mill, and we're just going to scroll down here until we find our 1/2 inch bullnose end mill. So this is going to be tool number 13, and whenever I switch tools, just make sure that you right click on that tool and we reinitialize these speeds and feeds so that our cutting parameters get updated. Likewise, down here in the comments, we do want to update this to a 1/2 inch bullnose. And then I just want to double check my available cutting length on this tool. So up here in the tool library, I'm going to double click on that 1/2 inch bullnose end mill, and this is going to open up the edit tool window. And as always, I never like making any changes here, but I just want to double check some parameters. So I can see that my cutting length is 0.59375. And while that might be good, I do not like pushing spherical tools past their radius tip. So this radius on this tool is 0.125, which means that my depth of cut per pass should only be an 1/8 inch. So I'm just going to keep that in mind when I'm setting that up in my cutting parameters, but I'm just going to come down here to cancel so I don't save any changes, and then I'll just jump down here into my cut parameters. So inside of cut parameters, we can see that our step over distance is 25%. That's totally fine. But here where it says step down, I can see that we're stepping down, if it was 50%, to 50 per pass. So I just want to update this to 0.125, or it's going to be 25%. And then we'll step up basically half of that. We can make this 12%. Next, we'll take a look at the stock that we're leaving on the floor and the walls. So we'll jump up here to our model geometry tab. And inside of model geometry, I can see that the stock that we left on the wall and the floor here is still set to 10 thousandths. I think I want to get a little bit closer before I move into my finishing toolpath with that ball nose end mill. So I'm going to update this from 10 thousandths to 5 thousandths. So double click on each one of these cells, and I'll just do 0.005. I'll click on this one for the floor, double click, and we'll make that 0.005. Now, the last thing that we want to do is activate our rest material, because we want to communicate with this toolpath that we've removed material from previous toolpaths. So think back to that 5/8 flat end mill OptiRough that we did for the first toolpath operation. And I'm just going to jump over here to the stock tab, and we'll click on that stock tab, and we want to activate or turn on the rest material. So we'll click that checkbox there, and instead of this looking at all groups for the previous operation, we'll hit the drop down menu here, and we're going to restrict this to only look at this toolpath group. And then we'll just hit the green check mark and let this toolpath regenerate. Now, this could take a little bit of time to actually calculate out. There's a lot of surfaces that have to be considered, and just to assure you that you aren't crashing your system, in the left-hand side in our operations manager, you should see an icon of a green ladder next to this toolpath, and that's letting you know that the toolpath is being calculated, and once it's finished, it'll actually regenerate. So once you see your toolpath regenerated, we're going to take a look at both of these operations in Verify. I'll select my entire toolpath group 1. You should see a check mark next to each one of these toolpaths, and I'll select Verify here from the top of the window. And this could take a second to calculate out as well. You can see down here that our playback bar is getting longer and longer, and then I'll just hit the play button to let this run out. And you can see the first toolpath operation is that OptiRough that we use the 5/8 flat end mill, and we're just trying to remove as much material as possible. The second toolpath operation here in blue, this is going to be the copy-pasted OptiRough, but we changed out that 5/8 flat end mill for a 1/2 inch bullnose end mill with a 0.125 radius in the corner. And this is getting us a little bit closer to near net shape because we reduced the stock to leave on the walls and the floor to about 5 thousandths. And that 0.125 radius is getting us a nice smooth transition between all of our steps. And this is going to make it a little bit easier for that ball mill to come in and finish all these edges with our equal scallop operation. So this looks pretty good to me. I think we're pretty much done with roughing. So let's go ahead and back out of Verify and look at our next toolpath. Now, I think I want to create a stock model that references both of these toolpaths. That way, when I run the next toolpath in Verify, I don't have to keep running these over and over again. If you look back at the duration, I bet it was somewhere around 1 minute, and you don't want to be sitting there for a minute every single time just to check a toolpath. So let's just make sure that we're here inside of our Toolpaths tab, and inside of Toolpaths, I want you to locate the stock section. We're going to find a gray half-pipe looking icon for stock model. Click on that icon, and this is going to open up the stock model window. We're going to rename this stock model to Rough Op, and then we're going to change it from this gray color here. We're going to click on the color palette. We'll make it something nice and bright like pink, and we'll hit the green check mark, and then we want to make sure that we are referencing the stock plane that we set up for this part. So I had to reorientate my planes. I created this new top plane, so I'm using that. And then I want to link this back to the stock setup that I created earlier, so click on stock setup so that we can recognize our X, Y, and Z extents. From here, we'll jump down into our source operations tab, and we're just trying to communicate with the stock model what toolpath do we want to run against it for material removal. So I'll just select my entire toolpath group 1 so that both of these toolpaths are highlighted. Just make sure that you're seeing a check mark next to each one of these toolpaths, and then we can come down here to the green check mark and let this regenerate. And this is going to take a little bit of time to calculate out because we are basically running both these toolpaths in the background. We can see that icon for the green ladder next to the stock model. And if you wanted to, you can go to the View tab and you can go to Multi-Threading and you can see all this being processed in the background. So once it's completed, we can hit the green check mark to close out of the multi-threading. And you can see that we've created a nice stock model for both of those toolpaths. So let's just jump back here into our toolpaths tab and we can take a look at our next toolpath, which is going to be the final or the finishing toolpath for Equal Scallop. So let's jump down here into our 3D toolpaths gallery, and we're going to have to expand this out, so hit the drop down arrow. And before we were looking at roughing operations, now we're going to be looking at our finishing operation. And in this finishing section, the first row, the third icon to the right is going to be Equal Scallop. So click on Equal Scallop, and this is going to open up your parameters window. Now, setting up this Equal Scallop is going to look a whole lot like setting up our OptiRough from earlier. We're going to have fields here for our machining geometry as well as our avoidance geometry, and we just have to populate both these criteria to create this toolpath. So underneath the machining geometry, we're going to go ahead and select some entities. So click on this little mouse button. We're going to hold down the Shift key and we're going to double click on one of these faces so that we select all the tangential edges in this cavity. We'll select End Selection, and you can see that we've now selected 103 entities that are being shown here in green. And the only difference from before is we were leaving like 5 thousandths on the wall on the floor or 10 thousandths on the wall on the floor. So we're just going to update this to 0 because this is going to be our final or our finishing pass. So double click on wall, we'll change this to 0, and then we'll double click on floor and we'll change that to 0. Next, we'll take a look at our avoidance geometry. Right now we have no entity selected, so we're going to come down here to select these entities. I'm going to select this top face, hit End Selection, and you can see that we have one entity selected and it's being shown there in red. Next, we'll move down here into our toolpath control. And as I said before, if your avoidance region isn't working, you may have to come back into this toolpath control tab to troubleshoot using the containment boundary. So just keep that in the back of your mind if your toolpath isn't working out. As far as the strategy, contain, and the compensate to, we can leave this all the same, and we can just move down here into our tool tab. Now, picking a finishing tool can be a little bit complicated at times, and I think a lot of people will assume that they have to use the smallest ball mill in their tool library to finish up some of these details. And while that might be true and helpful because you're trying to reach down into these tight areas, you might run into issues with the size of that tool trying to reach down to these deep pockets. And if you look at our tool library, we really only have 2 tools that can reach down this deep. And that's going to be the 1/8 ball mill, which is a really great tool. I use this for a lot of applications. However, something to consider with this tool is that it has a shoulder on it. And this shoulder may prevent you from cleaning up all of your edges before it hits the sidewall of the part. So this might not be the greatest application, and if you try using this 1/8 ball mill, you may not finish all of your edges. The other tool that we have available to us is this 250 ball end mill, and I think that this is going to be the best use case scenario for this application. If you look at these 2 tools side by side, they have the exact same holder, and the tool is sticking out past the holder the exact same length. However, with this 250 ball end mill, we don't have a shoulder to worry about because it's size on size with the diameter of the tool. So I think that this is going to allow us to reach down into those pockets and finish all of our surfaces with one tool. So let's find that 250 ball end mill here in our tool library. I'm just going to scroll all the way here down to the bottom, find that 19th tool, which is going to be that 250 ball end mill. We'll select on that. And for my comment here, I'm just going to say 0.250, and I'll say ball mill, finish. And then we'll just jump down here into our cut parameters. And inside of cut parameters, I'm going to leave everything here default except for one detail, and that's going to be the passes for our step over. Currently, this is set to 25 thousandths, and that might be okay for just trying to see how this toolpath will look, but for a finishing toolpath, you're probably going to start to see these step over scallops if you're up here at 25,000 step over. So I'm going to just decrease this down to 0.01, so 10,000 step over. That's still a little bit too much in my opinion. In industry, I might make it like 3 thousandths, but I don't want to crash your computer. So we're going to come down here to 10 thousandths, And we'll see when we click on the scallop height, this is going to get updated and it's going to be like 1/10 scallop height. So you might see that, but it still will be pretty smooth. We'll come down here to steep shallow. We can activate the minimum and the maximum depth. We can detect the limits, and you can see that 0 is going to be up here at the top, and then the depth here is going to be down here in the pocket. We'll go into our linking parameters. As I mentioned before, the full vertical retract, we want to update that, hit the drop-down menu to minimum vertical retract, and then we'll hit the green check mark and let this toolpath regenerate. Now, this is going to be one of those toolpaths that will probably take a while to generate here. So just be patient, and you may want to check in on your view tab. So if you go up here to view, you can go over to our multi-threading, and you can see what's currently being processed. It looked like that just finished up in the background there for me. But if your toolpath is taking a while, you can always just double check here in multi-threading. I'll hit the green check mark, and I can see that this toolpath looks pretty great for a finishing operation. So I'm just going to move my model around to make sure that we are cleaning up in each one of these deep pockets. It looks like we're not having any issues with reach. And if we zoom in here to these tool paths, you can actually see that there's these little blue overlapping lines. This is going to be your step over that we just created. So we set this up at 10 thousandths, and there's going to be like a 1/10 scallop in between each one of these lines. In industry, I mentioned that we're trying to go to like 3,000 step over, so these lines are going to get closer and closer together. So just keep that in mind with how smooth you want to make your part. You can always go back in your parameters and try to make those changes. However, I want to run this toolpath and verify to see how it looks against that stock model that we created earlier. So I'm just going to move this around and center this. And then in the left-hand side in my operations manager, I'm going to select that stock model, hold down the shift key, and then also select that equal scallop that we just created. Now, just double check that you only have two toolpaths selected. There should be a check mark next to stock model and then our equal scallop. If you see a check mark next to either one of these OptiRoughs, you're going to run them and verify when you try to play this out, and it's just going to take too much time. That's the whole reason why we made the stock model, to save ourselves that time from running those toolpaths over and over and over again. So have these two toolpaths selected. We'll come up here and we'll just select verify, and this is going to take a second to load. And we can see our stock model out here represented in pink, and it's going to have those two OptiRoughs ran against it. Right now, we're only trying to run that equal scallop, so we'll hit play. And we can see that toolpath start to expand out here from the center. So this is looking pretty good. I'm not seeing any issues yet, where it looks like we're cleaning up all the edges here at the bottom, and we have no issues with these sidewalls. The only thing that I might consider to change here, again, is that step over percentage or that step over rate, because you can start to see some of these scallops here. And that 10 thousandths might start to be exaggerated when you're going up an angle. However, if we make it like 3 thousandths, we might start to control that just a little bit better. And the only issue I saw here was the bottom of this edge. And that's because we have a flat surface with a sharp corner, and we're never going to clean up that corner with a ball nose end mill. We'd probably have to come back in with a flat end mill and just do like a contour or a circle mill, which isn't really that big of a deal. As far as the rest of these surfaces go, we did like 99.9% of it using just OptiRough and Equal Scallop. So I'm really happy with how we ended up here. I'm going to back out of verify, and we can go ahead and save this. I'll just right click, go to isometric. So if you ever wanted to do the right side mold, you can just follow this exact same workflow on the opposite piece. Or if you wanted to, inside of MasterCam, you could just probably mirror all these toolpaths over the y-axis. So I hope you enjoyed my explanation of this left side mold for the Arbor Press P2. Thanks for watching, and I'll catch you in the next one. Bye.